Hello, Paul Watts again here from High Flying Physics, supporting students wanting to get top grades at A-level. Here's another question which quite a few students have difficulty with, and it's to do with Newton's laws of motion. Have a go at it. So we've got a car of mass 900 kilograms that's being towed by a lorry using a horizontal rope. The tension in the rope when the car is being pulled along a straight level road at a constant speed is 150 newtons, and you can see the situation there in the diagram. Explain why there is a tension in the rope when the car is moving at a constant speed. If the lorry now accelerates at 0.5 meters per second squared, what's the initial new tension in the rope? And if the maximum tension the rope can provide before braking is 1,200 newtons, what is the maximum initial acceleration of the lorry if the rope is not to brake? Okay, so the first one is one of these explanation type questions, and most A-level physics students, when they see a third of a page of blank lines, go into a little bit of meltdown at this point. The idea of stringing a few sentences together is a bit of a nightmare. So let's just try and break this down. So what we've got to do is explain why there is a tension in the rope when the car is moving at a constant speed. The first job is to use some physics theory. And clearly, the first bit of physics theory which you just need to state is Newton's first law of motion. And you all know what that is. So objects either stay at rest or move with a constant velocity unless acted on by a force. Well, in this situation, we know that if the car didn't have the tow rope there, the car travelling along at speed would eventually decelerate because the car is being acted on by forces of air resistance and friction in the wheel bearings. So the car will eventually slow down. It won't travel at a constant speed. So what we can say, the tension in the rope is providing a balancing force to balance out the resistive forces acting on the car. So in other words, we can say that the resistive forces is equal to 150 newtons. Okay, next question then. If the lorry now accelerates at 0.5 meters per second squared, what is the new initial tension in the rope? Now they've used the word initial here because what they're saying is the car is still travelling at the same speed. So in other words, the friction and the air resistance aren't changing. So the tension in the rope is doing two jobs. It's overcoming the resistive forces, which we know from part A is 150 newtons, and it is also providing the additional force to accelerate the car. So we can put that in an equation. Tension is equal to the resistive forces plus the force required to accelerate the car, and that equals 150 newtons. And the force required to accelerate the car, well, that comes from Newton's second law of motion, which is F is equal to ma. So we can just put m times a like that, and we put the numbers in, and the answer comes out, as you can see there, is 600 newtons. Part C, a little bit more tricky, this one. If the maximum tension in the rope can provide before braking is 12,000 newtons, what is the maximum initial acceleration of the lorry if the rope is not to brake? So the starting point is the same as in part B. We know the tension in the rope is doing two jobs. It's overcoming the resistive forces and it's providing the additional force to accelerate the car. So we can write down the same equation again, and this time we're trying to find the maximum tension. And the maximum tension is when we are using the maximum acceleration. So as you can see there, maximum tension is equal to 150 newtons, the resistive force, plus m times a. A is our maximum acceleration, which is what we're trying to work out. Well, we know the maximum tension is 1,200 newtons, and then the rest is just maths, and we've got to reorganize that formula to give A max, and that comes out to be 1.2 meters per second squared. Good. I hope you found that useful, and we'll see you soon. Thanks. Bye.